Greetings, everyone. This is Eric Andelin, Senior Photogrammetry Workflow Specialist with SimActive, and you're joining us for the webinar, Mapping Corridors Without Control, Myth or Reality. And with me today, I have my guest, Joseph Heath Harwood, physical scientist at the U.S. Army Corps of Engineers Mobile District. Heath, say hi to everyone.
Sure thing. As Eric said, I'm Joseph Heath Harwood, go by Heath, and I've worked for the Army Corps of Engineers for going on contractor for 3, and 15 years for in the Corps. I work at the Joint Airborne Lidar Bathymetry Technical Center of Expertise. Very unique name for an organization. Yeah, it's JALBTCX as we're called, and we conduct bathymetric LiDAR surveys around the coastal United States, sandy shorelines for the National Coastal Mapping Program for the Corps of Engineers to support coastal engineering scientists around the Corps and all the districts within the Corps. And I personally, what I've been involved with the last 15 years as I've joined the Corps was about working with EO systems at calibration, planning, products, processing, anything above to do with any of our camera systems. We have a RGB phase 1 RGB 150 megapixel camera and a iTres CASI 1500 hyperspectral camera on board. So I handle all the product streams and any processing, any technical troubleshooting that we deal with is my role as kind of the EO guy here, subject SME kind of guy. So yeah, that's me.
Yeah. We're both then SMEs, and I noticed you have your engineer shirt on.
Yeah, this one's emergency operations shirt today, but we've done some emergency operations with the Corps and post-Milton most recently. Yep. We weren't exactly on scene immediately afterwards, but and actually we were based in Orlando, but we did do some East Coast and West Coast surveys for that.
Okay. Yep. Yeah. As I mentioned to you earlier, I was in the Army Corps 82nd Survey Detachment. I was a surveyor.
Okay.
Yeah, some 30 years ago. And that's when I said, I really don't like being outside. I'd rather be a photogrammetrist.
Well, if you got to cut lines for the topographic survey, that's no fun at all.
That was no fun, especially when it was cold outside, or in some foreign country. JALBTCX is a hard thing to pronounce.
Yes, it is.
It sounds awesome. It's like, man, what are these guys doing? But before we get into all that, let's go over the topics. And our topics are going to be planning for successful corridor mapping, and then setting up a project with direct georeferencing, understanding achievable accuracy, and then editing surfaces and mosaics to improve results. Direct georeferencing is a big deal for you guys because
indeed
you're sometimes responding rapidly. Sometimes, like you said, a lot of the times you're along coastlines. So
yeah,
the last time I remember, you can't put targets out in the ocean. So,
Nope, no, you cannot. And it's if you're doing base station work, and a lot of people don't do that anymore, but it's a little hard to get or if you're doing some type of triangulated network of stations, it doesn't really work that well either. Yeah. So yeah.
So fill people in on what your typical project size is.
We are planning to continue up the East Coast this year, but last year we started a little bit, and we started Georgia. We work our way up to South Carolina a little bit, and but that's like the goal for this year is to capture all the way from Georgia essentially to Maine. It starts to get a little rocky up as you get north in there, but sometimes we have we also have federal navigation projects that we like to survey, so we'll get up into those. But you're talking 30-kilometer blocks, okay. 18-mile blocks that we usually, that's our kind of standard, and we kind of hold on to that from our base station days, just trying to keep everything local. But we currently use RTX, so we essentially can PPRTX from POSPAC, Electronics POSPAC, but we essentially have a lot of freedom now But yeah, we're talking state size, coastline collects.
So
So
really, once you have access to an aircraft, it's fly from sun angle to sun angle and get as much as you can.
exactly, yeah. And that this is a little difficult with glint. We're definitely lidar centric, so in the EO perspective, it is tough on our EO system sometimes with glint. But yeah, we fly sun angle, exactly.
Okay, and like you said, you're capturing RGB as well sometimes.
Yeah. So RGB camera is just our phase one is just RGB. We don't have the near IR sensor along with that, but maybe one day.
Yeah. And typically, I mean, what is the ground sample distance you guys are trying to achieve? What resolution are you?
So we're flying at 400 meters, 1,250 feet. We're capturing 2.3 centimeters, but we produce products at 5 centimeters.
Okay.
That's our goal. Occasionally, we do pop up to 1,000 meters, and we produce products at 10 centimeters for those projects if we have to get, up higher altitudes for efficiency sakes.
And everything that you do is aircraft based, or do you guys tinker with the drones as well?
We do have drones. We have a Inspired Flight 1200, and we have a GeoQ system. It's a 660, one of the newest systems. 3 cameras on, 3 sensors on board, and then the lidar sensor, topographic lidar.
Okay.
We do want to get into the bathymetric space for UAS, but right now we're just waiting for those sensors to really kind of
Come to fruition.
mature us. Yeah. There's some good ones out there, but there's still hiccups here and there.
So typically, I mean, when you fly corridors, are they single flight line? Are they multi-line?
It's multi-line, yeah. 400 meters, yeah. We cover like a mile swath, so it's 500 meters inland, 1,000 meters offshore, and that varies. Obviously, your coastline's not always straight, so you may have a little more inland and a little more offshore. That's usually the case, but we try to keep them at 30 kilometers and a mile swath, or 1,600. We fly in reciprocal, but we just mow the lawn up there, go back and forth.
Okay.
So I guess not traditional, corridor as far as like power lines, but we do occasionally we do have some projects like that are more inland.
So when you break them down into, I remember said 18-mile segments.
Yeah, our blocks are usually around that size, and then they may be larger, maybe smaller. It depends on the coastline and the efficiency of that, and we try to really map that out for planning purposes.
So if you're flying at the same altitude and you know what your corridor length is and you know how many flight lines, you've got a pretty good idea of how many images you capture and have to process.
Yeah, exactly. Anywhere from 15 to 3,000 depends on, again, the width of the. Not 15,000, 1,500. Sorry. Yeah, so 1,500 to 3,000. I think I said that right.
So let's talk about some of the specific challenges with setting up projects for direct georeferencing.
Sure.
A lot of one, you get rid of survey, so or at least you minimize survey. You're not setting control points like that. So
correct.
So talk a little bit about what you're doing and how you set up a project.
Sure. We rely very heavily on our DIMS. That's really the key there. And accuracy of the seasonal sensor is what we use as input for that.
Okay.
We do collect control, but it's more as a QA/QC process. But everything's reliant on having an accurate DIM and putting that into SimActive. That's really where our key is. So getting rid of noise, getting rid of, and we use the DSM to DTM process in Correlator 3D. But setting the project is really, we're using like high accuracy IMUs, and we have the 610, the Planning 610 in the aircraft. We kind of have a hodgepodge of when we start talking as far as getting that EO processed. We had a RCD 30 back in the day, and we use the Planix, or sorry, not the Planix, iPass CO Plus software, which has Arena for the bore sighting processes. But the goal is to get an accurate bore sight. So we know our numbers are accurate. So we know what our inputs are going to be, have an accurate dim, and then process it through this using leveraging correlated 3D to kind of make some corrections if necessary. Not too many, because it can get a little squirrely sometimes if you let that let it slip a little too much.
So the seasmil sensor, explain that.
So the seasmil sensor is coastal zone mapping, imaging, and Lidar sensor. It was developed by Teledyne Optech back in the day, if anyone's familiar with that. And they have a very accurate. So they don't use any control for the seasmil sensor. That's how accurate it is. Not traditional topo. I think a lot of folks, they go out and map, and they have to use ground control to tighten up the data too. Seasmil sensor that's not required either. So our data is very accurate. I actually have a Lidar report for the seasmil sensor versus ground truth, and I'll show that later, possibly, if you'd like to see it. And that's what we rely on. We rely heavily on our Lidar data that we collect, and that's it's a bathymetric sensor, but we get accuracy of 20, a horizontal spot spacing of 20 cents on land, or 20 centimeters, and that varies offshore depending on the depths. So anywhere from 70 centimeters to 2 meters.
When you're talking about what you guys
Sure.
do, I mean, these are military grade, highly accurate positioning systems, which you then, I would assume, are capturing imagery at the same time, and you're using the same positioning system information that you're using for the seasmil also for the imagery.
Absolutely. Yeah.
Yep. So
very tightly coupled. Not something you spend a few dollars on. It's a little bit more than most people sometimes are willing. Yeah.
Correct. So just if you can maybe walk through a little bit of the differences of setting up a project with direct georeferencing versus one with control.
Yeah, we a lot of that's automated for us. As far as the AT solution, we use a constraint. I got that here. It's unconstrained, no EO adjustment. So that's how we run it through there. We actually listened to one of your, I guess, talks that you had a while back, and a guy came on. I forget his name, but he had a company, and he had a script that automated a lot of the as far as building the project, so you didn't have to open the GUI. We tried that for a little while, but we used the GUI to set it up. We used medium format, AT corrections, and then again we use the DIM solutions or DIM tools that you have to go from the DSM to the DTM. Again, that does rely on an accurate DIM input, and from there, it's just a pretty basic processing. After that, it's orthoing and mosaicing. As far as controlled, we've mainly used correlated 3D for our UAS projects with the controls, using control, and that's really kind of necessary. With the level and the cost of the IMUs on board, the accuracy is just not there, both horizontally and vertically. So you do need that control to kind of tighten it up a bit. And that's really the difference that in our space anyway, is where you're just using accurate DIMs and accurate interior orientation parameters, and that's really the key for us. Whereas with the UAS, we'll have to use a little bit more control.
Yeah, I would say the one thing for the folks that are watching is that when you're not using ground control, clearly you don't have to measure it. And if you have to measure it, that's a step in the AT that takes human involvement out. So you can run those scripts, even if you're not, running it from command line. Once you go into correlated 3D, you can go into the automation tools, say, okay, now once that I've got my AT set up and I got my DIM imported, I can run the script.
That's right. Yeah.
Yeah. And then I assume that when you guys go in, you're probably selecting the geoid you're working in with the tool, or is it already post-processed when you're doing the Lidar?
Yeah, everything's already right. We don't change it. We just set the horizontal essentially.
Let's talk about understanding achievable accuracy.
Sure.
So again, we're not talking about a situation where we have ground control all over the place, whether it's drone or aircraft. So understanding your accuracies can be challenging.
Well, again, we do collect PIDs along the coast, and we have a requirement to collect every 50 miles. We'll collect some ground truth and just to check our LiDAR data, right? So, and sometimes we extend that out, but depending on how it's necessary. But we go out and collect ourselves our own ground truthing data to QC our LiDAR data, but also we collect PIDs at those locations.
Okay.
So the goal is to check those accuracies and to see if we meet. The specs are changing. APRS specs are changing, but generally, it was, I guess, a geospatial data set and quality level 1 and 2 kind of thing. But now it's just based on their horizontal accuracies of your product, right? So our goal is to get 1 to 2 pixels. So we're producing 5 centimeters. Our goal is to be 1 to 2 pixels off, and that's on Seamlines too. And we usually are meeting those expectations. Now, occasionally, on the edge of our DIMMs, we do see a little, offsets there, but I think that's part of what, and we can cut those off if necessary. But to assess the accuracies, we use our PIDs that we collect along the coastline. Again, and that's depend on the range, but we usually every maybe 2 or 3 blocks we'll have a ground truth site.
Yeah, and for the viewers, if you're not using control, you're still more than likely going to need, like you said, some point IDs that you can throw in as checkpoints. You have the benefit of having captured and processed LiDAR data too, and you can bring that LiDAR surface in as a point cloud, convert it to an intensity image or whatever. And if you really want to make PIDs from that, you can. I'll tell you, I still think LiDAR is hocus pocus. I tell everybody that all the time. But it does work sometimes. And yes, once it does work, you can certainly use it for a multitude of other things. You're also using the phase 1 camera. The reliability Absolutely. Is certainly there, isn't it?
100%. Yeah, it is. I mean, those are amazing cameras.
Exactly. But my point is that you need to be working with a camera that you've been able to calibrate. You need to be working with a camera that's got quality lens.
Yes, of course. Absolutely, 100%. That is the key right there, is the camera calibration itself, both in factory, the metric calibration that they send, and then your bore site calibration.
And then along with that, since you're using a medium format, you're capturing a much bigger footprint.
Yep.
As compared to a drone. So
yeah, for an area that large, of course, that's it's the right tool for the job in those situations too, right?
So you're getting better geometry with a better camera, with fewer image footprints.
Yeah.
Well, tell me this. This is a challenge that you've got the seize mill that's capturing specific swath width, and you've got the camera that you're trying to match that. Is that correct?
Yep, that's correct. Yeah. So the original design in 2010 was to have a camera footprint that matched the seasonal footprint, which is roughly 300 meters. The phase 1 is actually a lot larger than that. It's around 400 meters. So we get a larger footprint, which is good for us because you end up, especially when you're doing seam lines and you're mosaicing it all together, those edges can have some inaccuracies in there. So it really works out really well. And it's great for seam line editing too, because you got a little bit more image to work with.
Yes.
And exactly. That is really nice.
Exactly. The days of capturing 60% forward overlap and 30% side lap are unnecessary anymore because you're not paying per image. Therefore, capture all the overlap you want.
And then we have about 50% side, 50 to 60% side lap and about 80% forward lap. And yeah, we're at about 1.5 seconds, and we're flying about 140 knots. So we're getting pretty good overlap, and it really works out well for us, especially on structures.
The last thing we can talk about, and maybe you can show us some stuff here, is editing surfaces to improve results. You've mentioned that you bring in the Seas mill surface,
Yeah.
or whatever you happen to have at the time, and you will use Correlator 3D's editing tools, help refine that to ground or whatever you're aiming for. Explain a little. I mean, you're talking again. Seas mill is water and land.
It is correct.
It penetrates to a certain depth in the ocean. Makes it a lot different than standard LiDAR sensor. Talk a little bit about that.
Yeah, sure. So we actually use the water surface from the Seas mill sensor. We leave that in our DIM creation, so that provides us essentially a smooth plane. We have produced DIMs and input DIMs into Correlated 3D that have the bathymetric surface in as well. But we're using a flat plane to create that surface on. Early on, we don't always have bathymetric data in some of these areas, so we learned quickly that there would be no image frames, but we still wanted to capture our block and have data there. So again, that's why we use the water surface. And really that works out really well. For structures, we do, as far as like have to edit the DIM, normally that's around structures. When I say structures, I mean like a jetty, and we have federal navigation projects that we collect specifically when we're navigating the coastline. And some of those are quite large, and they stand quite large off the surface of the water. So, and when you're going from DSM to DTM, sometimes that can get removed in some cases, especially when there's a water surface there, it kind of wants to smooth it out. So we have to occasionally either just go back and basically copy paste a DIM over that section, which is a great tool that Correlated 3D has, and we use it quite often. And other cases, we don't do a lot of DIM editing really, unless absolutely necessary. And that, which is great for us. It's great for knowing that we can rely on that DSM to DTM process to produce an accurate DIM for us and get the accuracies that we seek. But again, nothing's perfect, so we have to occasionally go in and put data back in. That's really the main cases that we use it for.
Yeah. Well, I mean, rivers and oceans are moving things. So
yes, they are.
I can talk from experience that if you are not using direct georeferencing and you go so far out in the ocean that you lost land, your ability to stitch those images together almost disappears.
For sure.
You can, as you said, you can put a false surface in, and with direct georeferencing, it's going to hold. It's going to say, yep, this is where my images are. This is the rotation. I've got a surface underneath me. I can go ahead and stitch together. But don't have that. Then it's relying on tie points and the AT. And if the AT can't put things together, it's not going to happen. A lot of people will call and say, hey, I'm not getting any imagery out here, and this is why.
Yeah.
Really want to, and you're along a beach, something like that, you could probably visually run a bunch of tie points between waves and things like that, but it's a manual process and it's not easy.
We've had to do it before. We've had to tie some stuff in. We go in and put our own tie points in to get some data. It was a couple years back, we did a Kwajalein island out in the South Pacific, and we had to manually add in tie points, looking at rocks beneath the ocean surface, and the occasional, I don't know, leftover beer can perhaps, or whatever was out there. We tried to tie it all together if we could find it. So
here in Tampa Bay, we have a lot of seagrass, a lot of scarring for boats and like that. So
Yeah.
we can usually tie out into the water if it's not too turbid, but
Yeah.
it's not something you want to do. That's for sure.
No, it's not. Again, we use the software for UAS as well. Not always, but occasionally, some of our projects we need that ability to edit those seam lines. Recently, end of last year, we were collecting an area up near Stony Harbor in New Jersey, UAS project, and we just had some bad seam lines that we couldn't get rid of, and so we brought it over into. I think we're using the GeoQ software, which in the background that's Metashape. And we just it wasn't really working that well for us, so we brought it into Correlator 3D, and we're able to clean those seam lines up and still meet good accuracies too. So yeah, it's one of the greater things that Correlator 3D offers for sure,
Very
and the
good.
ease of use. I mean, that's a fun software to use because you just throw it at it and let it go, and you get what you need out of it. So
Yeah, it is. It's very basic. I mean, we stay in our lane.
yeah.
Our menu, our GUI is very simple. So
Yeah, you're right. I know I did, and I know the people I've trained that are contractors. I picked it up very easily as well. Folks that are not necessarily photogrammetrists or mostly lidar processors, because that's usually what I have to. They throw me every once in a while. They throw me a lidar processor to help me process some data. So
great.
it's kind of nice to be able to. Hey, this is how it works. This is pretty easy. Here's the SOP. If you have any trouble, contact me.
And they look at it
Yeah.
and they say, "Hey, this is imagery. This is cake."
This is
Compared to
cake,
lidar.
exactly. There's some other software packages out there. It's not so easy, So,
Yep. So did you have a few things you wanted to show us?
yeah, I really kind of, and this is very. Can I share my screen
Yeah,
view here?
I'll
Let's
switch it
see.
over and put it on you.
I mean, this is very specialized software that we produced in house. When I say we, I say our contractor has produced. But I just kind of wanted to show you our. Oh, dismiss. All right. Again, it's in house and it's specialized to what we do. But I wanted to show you the DIM process, or at least show you, maybe not run through the steps, but I'm not. Hopefully, you can see this and make it. But I just kind of wanted to show you how we get to. We take dirty, essentially, data from SeasMill that has it's fairly refined as it is, but it needs some cleaning and editing. But we use last tools. We rely heavily on getting those last tools to create tiles, clear up the noise. I don't know if you can see that here. Get our ground. So we're using the LES files from SeasMill that are output, and this is no cleaning done. Again, this is all just algorithms that have been run on the data to input into here. So water service. Again, we use the water service, but no bathymetric data has been cleaned. No high points were taken out, but obviously with the noise in the ground, we clear that. Yeah, I'm not going to really go through the step by step, but I just wanted to show you kind of what our inputs are. This process creates our essentially input dim for the surface dim there. So it's kind of not much, I guess, but I wanted to show you also our camera section here. We have our basically Correlator 3D setup files that we create. So basically we take the input out of our iPass CO software, and again that takes the information from Applanix, we match it with the SBET, and we have some input files that basically just have like, this is the camera frame, this is a crude course navigation, and then there we just pair it with our interior orientation parameters, so our principal points, and then produce a McAfee kappa out of that. But anyway, that's essentially where we're just kind of processing that real quick here. We have some scripts that do create our TDF files. Everything's tiled to MGRS. So when we're outputting our mosaics, everything's a TDF file. And let's see here. Oops, let me close that. And then one thing we mentioned in our initial call was the IAQs.
Yes.
And that's just been a lifesaver for us because we were, especially, as you can imagine, if you get, 600 meg, 1500, 1600 meg files, maybe it's 300 megs in the raw format. You go to 1600 TIFF, you say you go to 16-bit or 8-bit TIFF file, depending on what we're doing. You're increasing your size, your footprint if you're producing a TIFF file to input into correlated 3D. So we can skip that process. In the last couple of years, we've been able to skip that process. So now we're just saving tons of space. But if you get 1500 TIFF files and you got to hold that data around for a little while, it starts to get expensive on the storage side. So being able to go from IAQs to straight to orthos and correlated 3D, and then of course mosaic, it's saved us a lot of time and money, of course. But anyway, this is all automated. That we just feed it the IAQs, and I'm kind of glossing over a lot of things here, but I just kind of wanted to show you what we do. Just far as we take the raw data we produced, we like a little ancillary check files. So we have KMZs that come out of this process. We can throw it in Google Earth or Arc Earth and just kind of get an idea. Okay, well, did we produce data? Do we have not accurate frames? Do we have data in our phase 1 camera? Just kind of quick looks there. We produce JPEG. So with the seasonal LiDAR sensor, we have a software that was produced by the Navy and ourselves over the last probably 15, 20 years. It's called PFM ABE. And that's what's used to clean and edit the data. And we actually have an image viewer. So what we do, we take the phase 1 camera images, we reduce it to a 25 meg or 25 kilobyte a scaled image. And so when the data editors are cleaning up the LiDAR data, they see a phase 1 camera image while they're cleaning the data. So it's a really nice piece of software, but we produce that in this step. Again, outside of the correlated 3D space, but a lot of different things. We produce inputs for all of our different streams of data. Essentially, is what we're doing here. Let's see, what else did I want to show you? Oh yeah, accuracy stuff. We do a real basic kind of QC here. I just I'll pull in the VR virtual raster that we create as part of our process for QC after correlated 3D, and I'll pull in, if I have a block that has photo IDs in it, I'll pull them in, and it's just a visual check. I do have scripts that will take will produce a little small LAS file for our ground truth area from the data, the seasonal data, and we actually have I forgot to mention this, we have a Galaxy on board. So when you mentioned reflectance, yes, we can pull photo IDs from reflectance, so a Teledyne Galaxy. But it's a very basic check as far as a visual check, so I kind of wanted to show a little bit of this, but so I will do a visual check on any control that I see that we have in a block and go, okay, well, that one might be a little bit off here. I have to go check back with whoever collected the ground truth and go, oh, did you mean the left side? Did you mean the right side? Or do you mean the center? So there's a little bit for me because I don't always collect the ground truth data. There might be another person out in the field that's collecting the data. So we'll do a visual check and then, say, oh, that's probably where they were meant to get there. So, and then I have a script that I run on the data that will take our PID control file and do some math and some differences between that and the image and the dim that we have. So the image, the mosaic that we have. And so, we kind of have a process for reporting this. It's actually produce a little PDF file, but for us, this was a block we collected in Hawaii, Oahu specifically, and there we had a ground truth location here. Unfortunately, our we forgot to clean our lens that day, but so it's a little and there's a lot of moisture in Hawaii, as you might imagine, humidity, but but anyway, it's a little site that we collected, and we're meeting pretty good accuracies here compared to our data. So we did have one kind of way off here, way off in left field. Not sure what happened, but we're meeting pretty good consistency. Our PIDs are looking pretty good compared to our imagery data. Since it's kind of separating like church and state, if you will,
Exactly.
it's good to have like an outside view just to make sure, okay, we're good. Yeah. So
You're exactly right. Let me take over the screen and I'll show some people maybe some things that they might be unaware of. So here we've got a project. It's not one of yours, but it's also phase one imagery. And this one has quite a bit of control in it. And from there, you could go and look at the accuracy report that we provide, which I believe is right here. Yep. So here's our accuracy report, and it gives you the information on the ground control points. But what we're really looking for is the ground control points and the results. So we have the results. These are the results. They're independent. They're from within Correlator 3D. But if, like you said, you want to separate church and state, then you can access these. And the way we would do that is to go into the folder system. And here we have the Correlator 3D folder. And inside the folder, we have the EO reports. And what you want to do is you want to go to your latest step right here. Go to reports. And this is where we found the quality report. But what you also want, or could want, is the GCP residuals. And if you select those, you'll notice this is just the raw version of the residuals that are provided in the accuracy report. So you could go in using a text editor and grab these fields, not all of these, but X, Y, and Z, and then take them into a spreadsheet or something you've created to compare those again against your surface, maybe in QGIS, but you would be getting your independent verification as well. So that's one thing I just wanted to point out. A lot of people don't know where that folder is and that file is. It's right here. And again, if you had checkpoints, you would have the same thing. You would have checkpoint residuals. In this case, we don't have any, but you could get those there as well. So be aware of that. It is certainly something that's useful. And again, for independent verification, that's where you're going to go to get that information. So you also mentioned the Seamline editing, and this project actually is, I believe, the same one you were talking about, where one of the other providers could not do the Seamline editing or could not do it well. So we'll go into Seamline editing tools, and we can select the block. Up here, we can select Seamline editing. And here we have our group of seamlines, green being its most confident, and then red and orange being a little less confident. But again, we're looking at marshland, so not a whole lot to work with here. Everything should be fine. And the mosaicing looks very good. So you could also go in and select a seamline and edit it. And if you do, it's going to show you the images that are associated with that seam line, at least the image footprint. So you have that as well. And then you could go in and, just grab it and move it. If you wanted to, you could save it. Everything will be good. You can say display the ortho or display the mosaic. I want to see both of them. Once you get it the way you want it, you can just go ahead and hit save and move on from there. So you can also adjust the feathering here. So that's good. And then you can mark and unmark a seam line as inspected. So if multiple people are working on a project, you can mark a seam line and the next person that come along will see it and not mess with it. So those are some of the new features of our mosaic editing tools.
Well, I think, you've given us a great overview of the program, of what you do, of what you expect of your subcontractors when you train them in Correlator 3D. Fantastic stuff. We really appreciate your joining us. Thank you very much. Did you have any other comments?
No, I don't think so. Thanks for having me. I really appreciate this opportunity. And, anytime I can advocate for using correlated 3D, I do. So I just want you to know that. And then, I met a couple of people over the last couple of years, and support's always been great for us. Anytime I need Daniel on the phone, he's very quick to respond. And I really appreciate everything that y'all do. And we've been using the software since 2016, and we have no reason to go anywhere else. So thank you.
Well, I'd like to thank my guest, Heath. Thank you. I'd also like to thank you, our guests, for joining us as well. If you had submitted a question during the webinar, we will answer right after we complete this session. A reminder, this webinar, along with all of our previous webinars, podcasts, and tutorials, can be found on our website, simactive.com, under the Learning tab. Once again, thanks for joining us. Until next time.